It seems so simple. You have a solid steel box and you need a window. You take a plasma cutter, trace a line, and with a shower of incandescent sparks, a piece of the wall falls away. It feels like progress, like the first real step in transforming an industrial shell into a human space. But that simple action, that first cut, is the most profound and dangerous moment in the entire life of a container home. In that single instant, have you just created a window, or have you fatally wounded the very structure you're relying on? To understand why that first cut is so critical, you need to know a secret about where a container's strength really comes from. It's not just in the heavy steel frame at the corners. The real genius is in a design principle called monocoque, the same concept used in airplanes and race cars. Think of an aluminum soda can. It's incredibly thin, yet strong enough to support your weight when it's sealed. But the moment you put a small dent in its side, it collapses instantly. A container works the same way. Its corrugated steel skin isn't just a covering, it's an active, stressed member of the structure. Each ripple in the steel works together with the frame to create a single, incredibly strong and rigid tube. Let's visualize this. In a simulation of an intact container under load, you can see how the forces are distributed evenly across the entire structure. The frame and the corrugated walls work in perfect harmony. The stress flows like a smooth river. But now, watch what happens when we cut a hole for a window. The moment the steel is removed, that smooth flow is violently interrupted. The forces have nowhere to go, so they concentrate intensely at the corners of the new opening. These corners become critical points of extreme stress, like a crack forming in a frozen lake. Without reinforcement, this concentrated force will begin to bend and buckle the steel, starting a slow but inevitable structural failure. And this isn't just a computer simulation. It's a real-world problem that has led to disastrous and costly failures. You can see it in poorly planned projects all over the internet. The roof directly above a large unreinforced window opening will begin to sag and dip over time. The walls around a doorway will start to warp and ripple, a phenomenon known as buckling. This deformation makes it impossible to install windows and doors correctly, causes seals to fail, and creates leaks. It's the container's way of screaming that its structural integrity has been compromised. What started as a small cut becomes a slow-motion collapse, turning a dream project into a twisted, unusable wreck. So how do you make a cut without triggering a collapse? The solution is as robust as the problem is serious. You have to give the forces a new, stronger path to follow. The critical rule is this. Before you remove any part of the original wall, a skilled welder must install a heavy-duty steel tube frame around the perimeter of the future opening. This isn't just decorative trim, it's a structural transplant. This new frame is welded directly to the container, creating a rigid, load-bearing subframe. Now, when the original steel is finally cut away, the forces that once flowed through that panel are safely rerouted through the new frame you just installed. It is a non-negotiable step that turns a point of weakness back into a point of strength. This brings us to one of the biggest myths about containers, that you can stack them like Lego blocks indefinitely. It's true that they are designed to be stacked up to 9 high on a ship, but that's only when they are in their original, unmodified form. All of that immense load, hundreds of tons, is designed to be transferred only through the 4 incredibly strong corner posts. The walls and roof are not designed to bear that kind of vertical weight. So, the moment you decide to build a multi-story container home and cut into the sidewalls of a bottom-floor container, you are creating a catastrophic point of failure. The load from the container above can no longer transfer properly through the corner posts. Instead, it presses down on your new, weakened wall and the steel frame you welded in. This is why multi-story designs require even more robust engineering. You're no longer just supporting the container itself, you're supporting the immense weight of every container you place on top of it. Ultimately, cutting into a shipping container should never be seen as simple construction. It's better to think of it as a surgical procedure. You are cutting into a highly engineered, load-bearing body, and every incision must be planned with precision and respect for the original structure. It requires the right tools, a deep understanding of how the system works, and the skill of a specialist to ensure the patient not only survives the operation but is just as strong as it was before. Approaching it with anything less than this level of care is the difference between a successful build and a structural disaster waiting to happen. If this look into the engineering of container homes gave you a new level of respect for these steel boxes, show your support with a like. And you'll definitely want to subscribe because cutting the container is only half the battle. Now you have to make it livable. In our next video, we'll tackling the most controversial topic in container building. We'll show you why common methods can lead to rust and toxic mold and reveal the single best technique to keep your home safe, dry, and comfortable. You don't want to miss this one.